Okay, the conduction of electricity in metal is due to vibration of ions. No, right? Vibration doesn't conduct electricity. Drifting of free electron in the metal, yes. Drifting of free electron in the metal is the voltage that causes the electron to drift. High random speed of free electron in the metal. That doesn't help. That is due to the temperature around the metal that give energy to the free electron. So that is not the one that's conducting. That is random motion. Collision between free electron and ions of the metal. No, that one cause heating effect. The answer is B. This is the one you got it right. Electric field strength is a right. Electric field strength is a force acting on a unit positive charge. This one also cannot do, so something is wrong. Capacitor of capacitance 20 microfarad is discharged to a resistor for mega ohm after 25 seconds. The charge on the capacitor is that. What is the time lapse when the charge on the capacitor is that? So do step by step. Right? Find the time constant. There's your C, there's your R. Calculate it out. Then use the formula for discharging. Right? For discharging, Q equals Q naught, E minus T. Put your value in. Right? You want Q naught, so take this one down, it becomes positive there. And put your value in. Your Q is given. You want to find Q naught. And then 25 is given. Time constant 80. Calculate it out. Then do again. Right? Use the same formula. This one. Take your Q down for that. Put in your value. So that's your answer. Okay.
Okay.
So copy what you want. Okay, number 4, okay, you got it right. Capacitor consists of two parallel plates in which the distance between the plates can be adjusted. The capacitor is charged by connecting the capacitor to a battery, which is then removed. The potential difference between the plate of the isolated capacitor can be increased by. Okay, just look at the formula there. Right? Electric field, your V is just E times your D, or E is V over D. The charge store is constant, right? Because you charge it up. You didn't remove the charge. Then you remove the battery, so the charge is constant. So A is wrong. Right? False. Touching the plate will discharge the capacitor and end with 0 PD. Bringing the two plates closer. Right? Remember the electric field is caused by the charge. So you bring the plate closer, and your potential difference will increase. Right? Your Q is CV, and then epsilon C is epsilon naught A T times V. So first one is false. Second one is false. Right? Decrease the separation, the charge is constant. You increase your V. Separation of plate further apart. This one is further apart. Remember, this is constant, so this one becomes. Sorry, you increase your D. So to keep this one constant, your V also must increase. Direct proportion. Right? So answer is C. Most calculation you cannot do. Means you have not put the effort to learn. Metal sphere or radius that has a maximum. That's your electric field strength. What is the charge on the surface of metal sphere? So I just memorize the formula. in your value, you want Q, take your 4 pi epsilon R, epsilon naught R squared to the other side, and put in your value 4 pi epsilon. Epsilon is there. R is there. Change it to meter square. Then your E, there's your E. Calculate out. Answer is A. Okay.
Okay.
This one is a very poorly set. Right? But the key is magnitude. Magnitude. So we are just using roughly this formula. Right? The rate vector is due to the positive charge, this positive charge. The blue one is due to this negative charge. So if you look at a point here, right, the positive charge, the red one will be to the right. The negative one also will be to the right. So you add them up between these 2 points, between these two charges, you add them up. So largest will be here, smallest will be in between. So that is the one. It cannot go to 0 because both of them are in the same direction. Then if you look at a point here, right? Remember the red one is due to positive charge, is far away, that's why it's smaller. Positive charge go away, negative charge it goes the other way. Okay, so in this case, the resultant is negative, right? That means not this part below. Whereas if you look at this side there, due to negative charge, right? The electric field will go to the negative charge there. If you look at this point there, due to this positive charge, it will go away. So it becomes smaller. As you go further and further, it becomes smaller and smaller. So the best answer is A. Right? But the real answer is this one if you consider magnitude and direction. Right? You just take the negative part and put it in positive. That's all. Okay. Very poorly said. Never do such thing. Okay with that?
Okay.
8, okay. Yeah, all right. Capacitor with an air gap between the plate is connected to a battery. Battery then is removed from the capacitor. Dielectric is then used to fill the air gap between the plate. Which statement is true about capacitor with the dielectric? Energy stored in capacitor increases. Right? First thing to remember, taking the battery, remove the source of EMF. The charge store is constant. That we know. Right? The voltage is no more constant. Charge store is constant. Adding a dielectric, what does it do? Increase the capacitance. Decrease the PD. Right? Because the capacitor is polarized. So electric field strength becomes smaller. Energy wise is half Q square C. You cannot use half CV square, right? Because your C changes, your V changes also. So you have to, Q is the only one that's constant and C is the one that is changing. So in an equation, you must choose an equation where one is constant. The other one is variable. Energy store decreases as C increases, yeah, from this formula. Electric field strength decreases because of polarization. Or easiest is to use this one, this formula, sum up everything. Q equals CV. Q is constant. As your C increase, your V decrease. That's the fastest one. The answer is C. 9. 12 volt potential is supplied to a cable with length of 50 cm. If the electric resistivity is that, what is the current density? Okay, go to your SPM. If you've forgotten, use your SPM formula, that's all. That formula. And then R is V over I. You are given V over I. Then these two are the same, R. So rho LA is V over I. Then put in your value. You want to find your current density. So you take your I across there, take your L down, take your resistivity across. You get this formula. Right? I over A is your current density. Then put in your value. Okay. A. Okay, let's go to the last one, number 10. Parallel capacitor is fully charged when an insulator is inserted in the space between the plate of the capacitor. Energy stored in the capacitor decreased by 73%. What is the value of the electric constant of the insulator? Right? That's the definition of the dielectric constant. Capacitance with dielectric, capacitance with non-dielectric. Charge stored in capacitor is constant. That's the key. So you have to use this formula, Q square over 2C square. That's the initial stored energy. And the final stored energy is the same, except we use a different C, that's all. And take the ratio. Right? Because you are told that the energy stored in the capacitor decreased by 73%. So cancel the half, cancel the Q naught. This becomes on the top there. So the ratio becomes 0.27. Epsilon naught, epsilon R is just C over C naught, 1 over 27. Right? Just inverse of this one. So that's your answer. Can. Can or not? Can or not?
Can.
The current of 15 ampere flows through a copper wire of side 10 cm. Assume each copper atom contributes one free electron. Density is just given there. Calculate the number of free electrons in copper cube. Right? There's your molar mass, and there's the number of atoms there. Right? There's your number of mole. Number of atoms divided by Avogadro's number, or the mass divided by relative molecular mass. So density is your mass over volume. Then just play with the formula only. Your M there, right? Take your MR across there. So you got your MR and NA divided by volume. So you want N over V, take your MR down and on to the other side. Take your NA to the other side. That's all. Put in your value. Okay, this is the number of atoms per unit volume. This is your chemistry work. Then, right, you want to find your number electron, and it's a cube. So the volume is 0.1 cube. Right? Change this one to meter. And multiply that, you get your answer. Okay with that?
No.
Don't bother to study, it's in your book. You better do something, I'm worried for you. No shortcut. Learning is your, you have to learn yourself. I can learn for you and teach you only. Okay,
Okay.
State the main factors that cause drift velocity of free electron. This one, okay. Basically, we just look at this formula, that's all. Drip velocity depends on electric field strength. So it's a accelerating voltage or electric field strength. Right? That's the main one. Then determine the drip velocity. You need to remember the formula. That's a basic formula. Right? Take NEA to the other side. Put in your value in. Okay. Okay, let's carry on. Determine the current density. Just write the formula. Put in your value. Calculate out. Okay. Number 12. A point charge, 0.2 microcoulomb, move into the region electric field. That's the region electric field with constant speed v, as shown in the diagram below. The electric field is established between the two conducting parallel plates A and B. That's A, that's a B, which are connected to a battery, 5 volt and minus 5 volt. The distance between the plate is 3 cm. Describe the path of the point charge which move through the electric field. The first thing, electric field lines are downwards. Right? It's always start from positive to negative plate. So what will happen? The charge experience a downward force. So experience a downward force, path of the charge is downwards, is parabolic within the plate, and if outside the plate, it's a straight line. That is provided it doesn't hit the plate. Okay. Calculate the electric field strength. 5 minus 5. Divide by, change it to meter. Calculate out. Determine the magnitude of the force experienced. This is a simple forward, right? Simple answer. Just that you don't put the effort to learn. Right? That's the electric field strength. That's the charge 2 microcoulomb. Change it to SI unit and calculate out. Okay. Okay, this is your homework. Make sure you do it and pass it up sometime the week. If not, I'll force you to do on next Saturday. Number 13, which you didn't do. Huh? Make a note, huh? Define capacitance. Okay, this one you can get it right. Ratio of charge stored on either plate to PD across the plate. This part you're all right. You can do it. Put in your value, epsilon naught, area. Right? There's your side. Change it to meter. So square that, get the area. That one, the D, change it to meter. Calculate out. Then the charge. Right? These are straightforward. Simple mark, you should be able to get it. Q is CV. Formula. Put in your value and calculate out. Parallel plate capacitor is separated by a distance of 18.5 millimeter. An electric supply of 12 volt is then connected to the capacitor, and the charge on the capacitor is that one there. A dielectric with dielectric constant 3.06 is then inserted into the airspace between the plate. Determine the electric field between the plate with airspace. Okay. Memorize the formula, that's all. It's not that difficult. V over D. Right? V is there. D is there. Put in your value. Convert it to this one. Convert it to meter. Okay, your answer. Capacitance of the plate after the dielectric is inserted. Okay, original one without dielectric, Q over V. Put in your value. That's your charge auto. And V is your 12 volt. Calculate your without dielectric capacitance. Then you are given dielectric constant. Right? C is dielectric constant times your C naught. Put in your value and calculate out. The increase in electric potential energy stored in the capacitor before and after the dielectric is inserted. Okay, so you are required to determine the electric potential stored in the capacitor before and after the dielectric is inserted. Explain the microscopic mechanism for the increase. Right? Initially, remember Q is the one that's constant, not V. Right? V changes as you insert the dielectric. So you cannot use half CV squared or half QV. You have to use Q is the one constant, C naught. Calculate out, put in your value, your Q naught. This one, change it to micro, square that. There's your 2 there. C naught, there's your C naught there. Calculate out. And final one, same formula, except C naught change to C, the one with dielectric. Right? Charge store still the same, doesn't change. 2, and then capacitance is that one there. Change it to SI unit, calculate out. Right? There's a difference there. There's a decrease. Inserting a dielectric causes polarization of dielectric, reduce the net PD across the capacitor, and then decrease the energy. Okay? Any question to ask? Anything not clear?
Okay, sir.
Remember, 13 you are supposed to do it and pass it up. If not, we'll do it on next Saturday. Unless you want to have another hours early this week. Okay, let's go to focus. I hope you have done your question. Okay, number 1, what's the answer? Kirchhoff's
6.0
law.
volt.
Answer? What's the answer?
Wait, you're talking about checkpoint 1, 15.1, right, sir?
Checkpoint, you have question to ask.
No, which one you doing? Focus or checkpoint?
I'm doing focus.
Oh, okay.
Checkpoint, we have completed already.
Yeah, 6, teacher.
Which one are you going to do now?
No, the focus objective. Okay,
Focus,
right.
number 1 can do. What's the answer?
Can.
What's the answer?
A.
Take A as a reference. Yep, correct. Number 2. Yep. What's number 2?
Donkey.
A galvanometer which has a resistance of 1 ohm gives a full-scale deflection of 1 milliampere goes through it. The galvanometer can be modified to measure potential difference up to several volts. Which of the following modified arrangement is correct? No, it's either A or C when you want to measure voltage or potential difference. B and D is to measure your use an ammeter. Right? So you have been studying your work. Multiplier determines the maximum voltage that can be measured. So you want to measure several volts, it cannot be A, it must be C. Yep. Okay. C is just you look at 1 ampere, 1 milliampere, 1 times 1, 1 times 1, that's all. Whereas this one is 1 times 10 and 1 times 1. Right? So this one can measure more voltage there. Greater potential difference is C. Okay, number 3.
Donkey.
Graph shows a variation of potential difference across a resistor with current. That's your V, that's your I. What is the current? When the current is 0.23, the power supply in the resistor, the 0.23 is somewhere there. Right? Doesn't matter, just estimate. You won't get it right, but the value are quite far away from each other. So it's VI. Okay, V 0.23 is about 5 or 4 something there. And choose which is the nearest. Right? B, not A. Right? Here we are estimating, so you won't expect to get the right answer. So the closest value is B. Number 4. Yep, number 4. Ten minutes time, we have to change a new Zoom. Yep.
Boy.
Okay, first part, always current law, Kirchhoff's current law, either take at P or take at Q. Right? There's your I going out, I plus I2, going in is I1, and put in your value. Right? Your I1, I2 is given. So I1 is 2.56, I2 is minus 1.64. Calculate out. Then you want to find the potential difference across PQ. Right? Current times resistance. A. Okay.
Okay.
This one. Potentiometer. Diagram shows the circuit where XY is a uniform wire. When the galvanometer is
C.
connected. Say again.
C.
C is it?
Mm.
When the galvanometer is connected at point P and point Q, then the balance tank is 44 cm, the resistance of R. Right? That resistance. Okay, we look at basically we are just taking ratio. Right? 100 over the whole ratio. 100 over 100 plus R. Okay, so over 100 is 40. over the whole thing is 44. Right? That's what we are doing. Cancel by 4, I get 10, and then this is 11. Then cross multiply, then simplify. Sorry, A. Okay. Yep. Any comment? Anything not clear?
No, okay.
Okay, let's go to the next one, number 6. Factory EMF E1. That's epsilon 1. Internal resistance R1 is connected to a battery of EMF epsilon 2. Internal resistance R2. Which of the following is true of the closed loop? Okay, W, X, Y. So we are taking it clockwise. That is direction. So use your Kirchhoff's voltage law. This is in the right direction. Send the current in the right direction. Positive. This one is opposing. Sending current opposing. That's why we got a negative sign there. So I1 times these 2 times your R1. That's what will happen. Right? Same direction. We add up. This one send current opposite direction. So it's I minus I2. And then I got R3, R2. So answer is B. Okay. Okay, we take 5 minutes break. We start a new Zoom. Any question to ask?
No.
Okay, now we'll take the 5 minutes break.